Hi there, welcome back. Well, we've got something completely different here again. This one is really different. This is something that a friend of mine has in Madeira to restore, and it actually comes from the States. As you'll probably recognize, the a radio station label, WBUC 1460 KCs. I believe it's in Virginia, I'm not sure. He mentioned it, but I can't quite recall. And what this is, if I can open it, yeah, it's in quite some shape. This is actually a microphone mixer, but it's all tube. Now, I've got to admit, I've never seen one of these before. I've seen mixers galore, but all tube, no. And this is not one of those fake tube mixers where they, they do solid state mixing and then they put a tube on the output as a sort of tube preamp. This is actually all tube. And the condition is not quite the best. This thing has seen quite a lot of work, quite a lot of hard living. And according to my friend, this thing was actually a kit. This thing was built by probably the engineers doing the recording. And this was actually supposed to be a mobile unit. This thing operates on the typical US power, 110, 120 volts, and it's got the two-prong plug. Not polarized, very primitive, as you can probably tell. And what do we have here? We've got mic 1, mic 2, mic 3, and output. So you've got 3 XLRs or balanced inputs for microphones. It's got 50 ohm written on there. And then there's a balanced output, an XLR output, that says 600 ohms. Now, I've actually opened this and the initial shock has worn off. So you'll probably go through it as well. But I'll tell you why. This thing was home built. It seems to have been built by someone either from a kit or somebody's design was implemented here. There's a VU meter for your decibel output level. There's a headphone out and a headphone volume out. And then you've got your faders. You've got your fader 1, fader 2, fader 3, and your master gain. Now, this thing should be quite simple, but we'll see when we get in there. All you need to do with 3 inputs is really change their levels and feed them into a summing circuit, an adder, and then in the end you'll have some sort of buffer with a volume control, maybe with a bit of gain. But this thing is interesting for another reason, and I'll take it out of here and show you why. It's only got 2 screws on the front here. The other 2 have gone walkabout. So let's get this out of here. Got to feed the power cord to give it some play. And now when I turn this thing around, you'll see what I saw. Keyword being I saw. Just kidding. I love these things. So let's have a closer look. At the top here we can see the power transformer, 1 filter cap. There's a hole in there which I believe was from another filter cap. There's a tube here, the little thin one I believe is a rectifier tube. There's no schematic for this. I'm probably going to draw it. We have a 12AX7 on the right here, which probably is the output buffer. And this is where it gets interesting. This thing has got audio transformers, which are pretty expensive to get hold of, especially these original ones, if not impossible. And it hasn't got 1, it's got 4. There's the output one. And if we go down here, we've got 3 more. And that is obviously from the 3 input circuits, from the microphone inputs. So this thing has got 4 of these audio transformers, And you can get similar ones. I know Lindahl does them, Sauter. Very expensive, very, very expensive to get hold of good ones. And I'm hoping these are very good. And we've got another few things here. We've got 3 Sprague. These, I believe, are paper and oils. Very good capacitors. Probably going to be okay. The rest, well, I don't know. This was a pretty rough job. Sorry, Livy, it's I'm talking about the equipment, not your work. You didn't do this. This is my friend. Somebody built this, and I don't know how neat it was originally, but it's had a lot of hacking on it. You can see that there's some tape in there. Now, that's not to say that this thing doesn't work. It probably does, although I'm not going to find out just yet. But some of the wiring is pretty iffy, and this is where it gets tricky, because this is a preamplifier, effectively. This thing is amplifying the microphone levels, which are very, very low level. So you need a very, very clean amplification. You need a very quiet circuit. And the way some of the wiring is done here, I'm not sure that that's as quiet as it could be. In fact, I'm probably willing to bet this thing is as noisy as hell. He told me that this thing hums like crazy, but that's probably the output, the filter caps. But other than the humming, I'm not sure how quiet it's going to be. If you see here, they've used all sorts of wire, not any sort of uniformity going on. The resistors are all very, very old carbon comp resistors. A lot of them will be out of spec. The capacitors, those 3 Spragues, are probably going to be good. There are a couple of paper caps. There's one down there. I've seen a couple more, but let's have a closer look inside here. We've got some ceramic capacitors, some film caps. There's a whole mixture of stuff in here. Those resistors sort of hang in the air, which is a bit of a problem, because of course this thing's working at high voltage. Common bus, a ground bus, that wire that goes across there is the common ground, which is very advisable in these things. But also the signals are coming to the input, to the grids, via a shielded cable, which goes over the top, and I can see that cable coming out here, and then going to the jacks, or to the XLR connectors. There are a few tubes on here. I'm not even sure which tubes they are, but it's difficult to see. But there's 1, 2, 3, 4 tubes at the bottom here, and they are behind these transformers over here. You can probably see them there. But here's the thing. I need to get this thing to work, and I need to get it to work well. So I'm thinking that I'm probably short of options other than dismantling a lot of this and rebuilding it, because a lot of the problems with noise on these circuits, especially at low level, like a microphone level, preamp level, is going to be owed to bad wiring. The way you wire it, not the wiring itself, but where you put the wires. You call it lead dress. And there are a few rules you should follow. Things like keep the AC lines away from the sensitive DC. Make sure that the heater wires, which are 6.3 volt ACs, are as close as possible to the chassis itself, and twisted. That's the other thing. They're supposed to be twisted, and I don't see any twisted wires going to the tubes. But it's very difficult to see as it is. But this comes out in 2 sections. This section here comes out, and then this section here comes out. I don't really need to remove this one, but I will need to remove that one so that I can get in there. I can see a paper cap down there. The power supply is probably going to need to be completely rewired, because I don't think some of those, I know some of those resistors have overheated, according to my friend, probably due to shorted filter caps. Some of them he replaced, and I believe he replaced them with good caps down there, Nishikons, but I need to see how they've fitted in there. I want to try and draw the schematic. So this is going to be an interesting project. The only reason I'm taking this on, well, there's two. One of them is I find these things fascinating. I'm really interested in them. And the other thing is that it's a very simple circuit. Even though you don't have a schematic, and even if you couldn't draw it, you can sort of figure out what's happening here. It's not too complicated. And of course, this thing works on 120 volts. So he came and, well, he's got a 220 or 240 to 120 converter transformer. This thing is an actual transformer. It's an auto transformer. It's not a primary and secondary. It's just one winding with a tap on there at halfway. It's only 70 VA, but it should be fine. I'm still connecting it to the, I'm going to connect it to the dim bulb limiter, just in case, because I really don't know what's happening here. And before I check the actual power supply, I don't think I'm going to switch it on. So I'm going to get cracking on here and report back as and when things get interesting. Well, I've got these two parts separated. I've left that section still bolted to the faceplate, and I've managed to remove this one carefully. I desoldered a few connectors, making very sure that I recorded what I desoldered. I also disconnected the pot and the headphone jack from the faceplate. So yeah, all we've got here is the power transformer, filter caps, the output transformer, two tubes. One is the rectifier tube, one is probably the output buffer or preamp tube. There's another hole down there which I think had another one of these caps, and because I see quite a few capacitors on the underside. These guys were probably inside a filter can, and okay. Okay, that's interesting. Let's have a closer look. So what do we have here? We've got the transformer power, the AC power coming in here, goes to there, that one. So this is the main power. That goes to the two anodes of the rectifier tube. That is what went to the little meter at the front that I desoldered, but I need to see where they go. I'll be able to draw out the schematic quite easily here. I can see the underside of the main filter caps here, multi-section cap, and I'll be able to clean up this wiring. I think, what are these? This is probably the heater. Yeah, this is the heater supply, it seems. That'll be ground, connected to ground over here. Okay, that's ground, heater supply over there. Somebody's been here. Okay, so we'll clean these up. These wires should be a little bit thicker because these heater supplies do take a bit more current, and they should be tightly wound together. These actually are wound together, which is a good thing. So I'm going to look around and see what has been done here. These were obviously the legs of that filter capacitor, because you see a resistor coming from the supply, resistor, capacitor to ground, resistor, capacitor to ground. That's a usual thing, and it was obviously a dual cap. I think my friend actually did this. He told me he replaced that filter cap. These resistors I'll have to check. Some of them look a little bit dark. And then of course here you've got the output section. So we have to be careful with some of these wires floating around. I'm trying to see where the heater, yeah, here we go. Here's the heater supply, and it's flowing back right through other supply lines. I believe these are probably, I think what happens here is that each tube, and there are four of them on the underside, have a capacitor. So they're filtered between each section. And therefore, these would be the B pluses going back. Now, okay, it's one way of doing it, but there might be an easier way of doing that. At least there'll be a cleaner way, but there might be an easier way of doing that by actually certainly not running it right by the output transformer, but there might be an easy way of doing that. I'll have to just study this a bit more and see how we're going to go from here. Okay, let me get going. Right, enough music. Let's get down to the nitty-gritty. Quite a lot has been done here. The quick slideshow that I showed you was just to give you an idea of what an intermediate step on this looked like. Nothing too dramatic, but let me tell you what I've done. I basically rebuilt the whole thing, and the reason was when I started measuring the resistors, they were completely kaput. All of them, practically all of them, were over their spec or out of their spec. So I decided to just do a clean sweep. There are a couple of exceptions here. Things like that capacitor there, that was perfectly fine. And this is actually an audio coupling cap. It's measuring perfectly fine. I measured for leakage on the capacitance leakage tester. No leakage whatsoever. These two caps have been put in recently. These are Illinois capacitors, so they're fine. They're also audio coupling. Now, what have I done here? Well, I've rewired this quite a bit. I've taken the B+, these are the high voltage supply, AC. This has got a center tap, so we've got minus, 0, plus, although it's AC, it's just the phasing. So I'll presume this is something like 200 volts, 0, 200 volts. Those two go to the anodes of the 6x4 rectifier over there. The output of that rectifier from the cathode goes to the first filter cap. Now, about this filter cap, the owner said to me that I should check it, and I'm glad I did, because it seems almost as if this has been replaced already. It doesn't look original, and in fact, when I measured it and did a bit of reforming, this thing was perfect. I mean, I got to the point where I connected all the capacitors together and measured their leakage together. I had already measured them separately, and the leakage came to about 700 microamps at 350 volts, which is as high as my leakage tester will go. So this thing is perfectly fine. And I had measured individual ones because you could have all of them perfectly fine and one of them gone, but they're all okay so far. So I put it back. What I did do is I rewired everything because it was an absolute mess, and the resistors were out of spec, different types. I just didn't trust this. And the fact that this thing is humming sort of led me to believe it could be the cap or even those two, but we'll get to that in a second. So this section here is B+ comes in. It's filtered by the first 20 microfarad capacitor. 20 microfarad is perfectly acceptable for that rectifier. I believe the maximum you can have on the first cap is 40 for the 6x4. And this is fine. And then so you get your first B+ over there. Then there's a resistor that goes to the second capacitor, and you get your second B+. Another resistor to the third capacitor, and you get your third B+. And then from there are actually 3 offshoots, all of them with 3.3K resistors, going to another capacitor. So that's B1+, B2+, B3+, and then from B3+, you get another resistor to another capacitor, which is B4+, and from there it goes to another one, which is B5, and then B6. And these two capacitors were the ones that were in there, but I did put a terminal strip over here just to clean it up, because it was sort of floating around, as you may remember. And then I got to, the heaters. Okay, heater wires over here. The one thing that, by the way, just going back to this, there is sort of an accepted formula for the allowable leakage that you can have on a filter capacitor. And that is, you multiply the capacitance in microfarads by the voltage in volts, multiply by 0.03, so 3% of that, and you add 20. I know Sencor, I believe, uses it, and you can find references to that in quite a few places. So if you do the sums for this, and you, like I did with the joint capacitance, 4 by 20 microfarads is 80 microfarads, times 450 volts, which is their rating, times 0.03 plus 20, it should allow for 1.1 milliamp of leakage. So 1,100 microamps. So the fact that I've got 700 is good news. Carrying on, heaters. Okay, the heaters here, coming out of here, it's one side is obviously connected to ground. I've created a common ground bus, which was sort of there, but pretty iffy. So it's got now a new tag on there. with one of those, what do they call those things? Those scratchy washer things that sort of bite into the metal. Can't remember what it's called. But anyway, that's there. It also goes to the ground or the negative of the capacitors. And I've connected the ground of the capacitors is obviously the can itself, the shell. So I've connected it to 2 points on the shell, so it goes across the bottom there. That's 0 volts. And that too then comes to this ground here of these capacitors. So everything, the ground is actually pretty concentrated here with nice thick wires, so you don't create ground loops. Ground loops for me in this system are a great concern, and you'll see why in a second. I think this thing was done with very little consideration for ground loops. So I'm pretty worried about what we're going to get at the end. But we'll take it one step at a time. So heater wires go to there. They have, basically I've taken the old wires out, put thicker wire on here. The reason is we've got 4 tubes on the bottom section and 2 tubes at the top. I know the 12AX7, 12AU7, I believe this is a 12AU7. They all consume 300 milliamps at 6.3 volts. With these tubes, you can wire them as 12 volt, or you can take the 2 heater wires, put them in parallel, and you've got a common ground wire for the heaters, which is the pin 9, and you can run them at 6.3. But in that case, it draws 300 milliamps each tube. Okay, so each tube drawing 300 milliamps, that's 4 on that side, 5 here, so that's already 1.5 amps. 1.5 amps, okay, at 6.3 volts. Then you've got the rectifier itself, which I believe takes another 300 milliamps, so that's 1.8 amps. And then these little guys coming up here, this is to light the lamp on the VU meter, and I've actually measured that. It draws close to 100 milliamps. So you're talking about 1.9 amps that was being drawn through those little thin wires. Obviously, as it goes from one tube to the next, the ongoing section carries less current, but still, you shouldn't run heater wires with that are underrated to try and get the heater supply to your system. They also have to be very well wound or turned or twisted. And so this is what I've got going on to the bottom section. It hasn't been connected yet. I've got 2 wires here. I've tried to keep the color codes they've got, although they don't respect the color code really, but I've kept it more or less the same. And these have been wired, and the way I do this is you connect the end into a drill, hold the other end and just twist, and stop when you're happy with the twist. So you do the twist and that gets done. All right, next. What else is here? As I said, these resistors were changed. These are now all fine. And now we've got 4 wires coming out of here, all nicely pushed to the bottom there. This is not stuck in. I've got to find a way of keeping it there, but they're all close to the chassis, which is what you should do with supply lines, as well as the AC, especially the heaters, should be as close as you can to the chassis so that it doesn't induce hum into your audio circuits. And now I've got these wires, which are the various high voltage supplies to the various tubes on the bottom section, which I will have to connect. But I'm taking this, as I said, one step at a time. Right, next we've got the transformer in there. That output transformer there is wired as a load. The primary of that transformer is wired as a load to one of the triodes of this tube. This is a 12AU7. This thing is cathode biased. There are 2 sections on here. It's cathode biased. Both sections are actually individually cathode biased. There's no cathode bypass cap, but they're cathode biased, and they are, the B plus on the one triode is fed through that transformer, okay? And the other B plus, this is the first B plus, if you see this point over here, goes to that transformer. It also comes back here to that one there. Actually, it's the second B plus. If that's B1, that's B2. And that then feeds the second triode through a 47K resistor, this one here, to the second triode of that 12AU7, or ECC82, I think it is. So we've got both tubes biased, both triodes biased. One triode has got the transformer as a load, which means that it induces the signal across the primary, and which in turn gets induced into the secondary. The secondary is coming out here. So this is really the output. Okay, if you look at a tube amp, now remember this is a preamp really, but if you look at a tube amp when you've got a transformer there, this would be sort of the 4 ohm or 8 ohm output. Okay, now this thing cannot be switched on without a load. So we'll have to see what happens when we put this into the into the faceplate there. The load itself, which is the output to that, that connector there, actually you can sort of just see it over there, the balanced connector, that's your 600 ohm output. That thing has got an attenuator network on there. It's got I believe it's an LPAD, which will serve as a basic load, even if that is not connected. But it's an attenuator, and I think it's about 4 dB attenuation. I'm not sure. I'll check that when I get there. But I've then also changed the wiring on this. This thing had just a twisted pair of, looked like sort of the Cat 5 or Cat 6 network cable. When you strip the thing and you've got lots of wire inside, it looked like that. This thing is proper low capacitance wire, audio wire. It's got a shield and it's got 2 connectors on there. So, you've got the hot and cold, and if we want, we can connect the ground as well. I'm not sure. This had no ground, and this is where I'm getting concerned with hum, but it had no ground, so we'll see how we get along. If we need ground, I can actually connect ground to this as well. Okay, so that's the output changed. These connectors are what worry me. This thing is sort of the input to this section. Now this section, as I said, it's got a triode that's driving that transformer. So the input signal is actually the mixed signal from the other tubes, from the inputs, okay? So this is sort of the summer or the buffer of the summed audio. And this is going to the other bottom section, but the ground of this thing is not connected. It's soldered to the center pin, or that center cylinder of the tube, which is not grounded. So they're sort of counting on you taking the signal from there. Maybe this is grounded at the other end. Maybe it's properly grounded, I'm not sure. But nevertheless, this thing is a recipe for ground loops. I have not changed that yet, but it's very easy to make the ground point down there as well. I'll see how it works when we start operating this thing, and we'll decide then. What else have we got here? This thing here, the output from that first triode, okay, the output from the first triode comes out, is coupled or decoupled through this capacitor. So the DC that's on there, it's on the anode of that tube, that's the output. That DC is kept out and the signal goes through and goes to that connector point there, that tag point, and it goes up here, again without a ground. This is really worrying me. This has got no ground on here. It goes to the top of the volume pot for the headphone out, okay? And the return with ground then comes to here. And this one is grounded. So, okay, so the pot is grounded. That's grounded there. And the output from the pot, in other words, you set the volume level, and that goes to the grid of the second triode. So that second triode has got one purpose and one purpose only, and that is to amplify the signal with a volume control in it, the signal that your transformer is getting, so that you can control the volume of your headphone output, okay? And then the output of that tube, the anode of that tube, which is the output of that triode, comes through here, is connected through a coupling cap of 0.1 microfarads. This is a 850 volt DC cap, okay? That is connected to that point there, which then has this yellow wire. Hang on, I've bent stuff here. This yellow wire goes to the top, and that goes to the output jack, again with no ground. So the output jack's ground is actually the connection it makes to the chassis, and that's it. Not a good idea, but we'll see how it sounds. And I just wanted to do this, show you this section, show you what's happened and what has been done, because the next stage is I'm going to fit it onto the chassis over there. I'm going to connect the output, which is this guy, and I'm going to obviously test the power transformer, which I haven't tested yet, make sure these guys aren't touching anything, and measure the voltages. I would expect that most of these voltages, if not all of them, will be exactly the same because there's no current being drawn. Okay, as soon as the caps charge, no current is being drawn from here. Therefore, the voltage drop across those resistors will be 0. Therefore, the voltage you see here will be the voltage you see over there. And because no current's being drawn from there to there, that voltage there will be the same as that one. And, okay, at some point there'll be current draw, but we should get very similar voltages. So I decided to take a break here because I want to do this. I've got to check some things here, but I do want to show you the schematic. I've drawn up the schematic from this and I've cleaned it up. Let me show you. Let me show you how it goes in 2 steps. This is what the schematic looks like when you're drawing it as you check the wiring, okay? A bit of a mess. Make sure you make notes, lots of notes, because you'll be surprised how often you have to look back to there. I've also taken photos of this before I started desoldering everything. It's pretty simple, but I'll show you the cleaned up schematic now. The first stage here is the power supply. We have AC 120 volts coming in. There's our transformer, ground, the 2 taps, center tap transformer going to the anodes of the rectifier tube. The cathode is the output. That goes to the first filter cap, 20 microfarads at 450 volts. It's one section of that multi-cap. And then you've got 1, 2, 3, 4. These 4, 1, 2, 3, 4. These are all that one cap, each with a resistor between them. So basically you get respectively lower voltages and more filtering. I call that B0. I think I called it B1 in the previous section, but it doesn't matter. B0, B1, B2, and then B3. But from B2 rather, it goes off again from here and it goes through another resistor capacitor, so you get 2 more B pluses based on that one to respective sections of the tubes. That's fine. Over here you've got the heater winding, which at the moment I've only checked the rectifier tube and the 12AU7. Obviously there's more going on there, and there's also the lamp for that meter. But nothing too dramatic here. Lots of filtering. This is lots of filtering. Every section is basically isolated from the previous one, which is a good thing. The one thing that worries me is that they haven't taken as much care with the grounds, these grounds over here, and also obviously the grounds over there, which is more important. So I'm not too sure about what the ground loop situation is going to be like. If we look at the most important part, which is that the output tube, the 12AU7, or the ECC82, I think that is. We've got the input coming in here. This comes from the mixer stages. So this is your result of all the mixing. Comes in here. 270K grid leak resistor and a cathode biased triode. One section of the tube. Now this is cathode biased without a bypass capacitor. Pretty normal. And this 270 seems a bit low, but I'm not sure what the 12AU7 likes. Won't make any difference. This triode has as load the primary of that output transformer, which is fed from the B1 plus over here. So whatever audio comes in here is amplified and is generated across that primary. It then induces it across the secondary, which goes on to the stage we're going to see next. The same audio output, the same signal that's seen over here, generated across the transformer, also is sent off by 2 capacitors. This one over here, which is one of those yellow ones at the back, and I'm not sure what it does. I think it's a feedback. I've recorded where I desoldered it, so I'll be able to see what it's doing when I do the bottom section of the chassis. But this one here is that one that I said was in perfect condition, that brown one. And that goes off to a pot, a 500K pot, the top of the pot, the wiper of which is the signal that feeds the grid of the second triode. In other words, we're taking the output here, feeding it back and altering its amplitude if we want to, and feeding the next triode. Obviously this thing is AC coupled. We've got the DC blocking capacitor over here. So that then receives a signal, you change its volume, and it comes out of the anode, and it's fed from the B plus through a 47K resistor, your anode resistor, and then it is connected through this cap, so DC blocking again. The audio gets through to the headphone socket, the tip of the headphone socket. The problem here is that the ground of the headphone socket is connected straight to the faceplate. There is no ground connection directly to here, which is where it should be, or to there. So I'm not sure what that noise level is going to be like. As I said, this ground loop situation here, the potential for ground loops is quite high. I'm not sure what we're going to see, but I guess we'll wait and see. Then I'm going to do the following. I'm going to take this section, I'm going to put it back into the faceplate, I'm going to connect this section here, look at the attenuator network that I know is on that output socket, and I'll be testing this whole section, the supply, and also this section, and I'll be able to report back very soon on that. So that's it for now. I want to thank you for watching. I hope you've enjoyed the video. If you have, click like, share, subscribe, and all that jazz, and I'll see you back soon for another one. Bye for now and stay safe.